Hello and welcome. My name is Jewel Zingrich, and today we will be working through the Exam 1 Part 1 problems together. So let's begin with Problem 1. Problem 1 states that it wants us to use a pair of numbers. So we'll have our pair, our two numbers, and it also states specifically counting numbers. So we should remember that that won't include 0 because our counting numbers are the ones that we can begin counting with our fingers. So 1, 2, 3, and so on. And then it wants us to find that pair that have both a greatest common factor of 8 and a lowest common multiple of 120. And so I prepared this number before class. I have 24 and 40, and then we're going to use this pair in the methods we've learned in class to prove that this number has both the GCF of 8 and the LCM of 120. So this problem didn't specifically state which method we needed to use, so I chose to do set intersection for this problem. So let's begin. To begin, we create sets of the factors of both of our numbers. So we'll begin with 24, and this is a set, so we start with our braces, and we go 1, 2, 3, 4, 6, and so on with the factors of 24, 8, 12, and 24. Then we make sure to end with our braces on the right, and we go to 40 and do the same process with the factors of 40. 1, 2, 4, 5, 8, 10, 20, 40. And we end with our braces. And it's important to know there's no ellipsis at the end here. So this is a finite set of numbers. And so we're going to go through these factors that we found and see what is the greatest common factor. So we're looking for that greatest common factor of that 24, 40. There's our notation. So let's start. They have 1 in common, they have 2 in common, they have 4 in common, but we're looking for the greatest. I see if we keep going down, the greatest they have in common is 8. So we proved through the set intersection method that the GCF of both 24 and 40, that pair of numbers, is 8. So now we're going to also be using the set intersection method to do the same process, but for the lowest common multiple of 24 and 40, which is 120. So this process is similar, but what's different here is the sets for 24 and 40 instead of the factors are the multiples. So we're going to start with 24, 48, 72, 96, and I'm going to stack because I found 120. And it's important that I do have the ellipses here in the braces to show that this is an infinite set. This will go on forever. And then I'm going to do the same for 40, 80, and 120. Alrighty, so I end my element there. I included my ellipsis, and then we look. We have 120 on both sides. And so we proved that both 24 and 40 have the GCF of 8 and the LCM of 120 using that set intersection method. So now we'll begin with problem 2. Problem 2 states that it wants us to find the greatest common factor of 117, 195. And it states specifically in this problem that it wants us to use the Euclidean algorithm. So that's going to be what we go ahead and do. So the Euclidean algorithm is a series of long division problems using the smaller into the larger. So dividing the larger by the smaller in order to create our GCF. So we're going to start with our smaller number into our larger number. 117 can go into 195 one time. 117 times 1, 117. 7 from 5 we can't do, so we borrow from this. It becomes an 8, and now we have 15 minus 7. That becomes an 8. 8 minus 1 is 7, and 1 minus 1 is 0. So now we have a remainder of 78 and 117. We're going to go smaller into the larger, again, continuing until we have no remainder. 78 can go into 117 one time. 78 times 1, 78. So we're going to subtract by 78. We can't take 8 from 7, so we borrow from this 1. This becomes 17. 17 minus 8 is 9. We have a 0 here, and we can't take 7 from 0, so we borrow again to the left, and we take 7 from 10. We're left with 39 and 78, so we put 39 into 78. 39 can go into 78 2 times, and that equals 78. 78 minus 78 is 0. So the Euclidean algorithm states that when we have a remainder of 0, that the number we divided by is our greatest common factor. So our greatest common factor of 117 and 195 using the Euclidean algorithm is 39. Thank you so much.